Hi, this is Mrs. Kidman, and in this video, we're going to be discussing the fundamental counting principle. So this goes right along with combinations and permutations. So the fundamental counting principle says if an event M occurs in M ways and event N occurs in N ways, then event M followed by event N can occur in M times N ways. So really what this question is telling us here is, say for example, I had the event of picking a sandwich. And I had 7 sandwiches to choose from. And then I also wanted to get a drink with my sandwich, and I had 6 drinks to choose from. The number of ways that I can get a sandwich and a drink, the number of combinations that I can get together is going to be 7 times 6, or 42 different options that I can choose from there. So the fundamental counting principle says that for however many outcomes I have, for each event, if I take the number of outcomes and multiply times the number of outcomes for all of the other events that are following that event, we can figure out how many total outcomes we will see. So let's take a look at this next question here. So you're out on vacation and you need to pick an outfit by deciding between jeans or black pants and then selecting a blue, green, or red shirt. What are the possible outcomes? Well, for our pants, we have 2 options. We can either wear jeans or black pants. And then we want to multiply that according to the fundamental counting principle by our shirt options, which are blue, green, and red, or 3 options. So total I have 6 different outfits. Now we can list out these outfits, right? We can have jeans in the blue shirt, jeans in the green shirt, jeans in the red shirt. We can have our black pants with the blue shirt, our black pants with the green shirt, or our black pants with the red shirt. Total, we have 6 outcomes here. Now, instead of listing out all of the outcomes every time, we can use that fundamental counting principle to figure something out. And the reason why that's helpful is when we have something like this. So say you're putting together a combo meal at Culver's with a burger, a drink, and a side. How many different combos can you make with the following options? Well, with our burgers, we have 4 options. We have 3 options for our sides, and we have 5 options for our drinks. So the fundamental counting principle says that I can multiply these 3 things to figure out how many total combos I can make. And 4 times 3 is 12, times 5 means, that we have 60 different combinations there. So we've got 60 options that we can choose from here. 4 burgers, 3 sides, 5 drinks, 60 different combinations of those things. Okay, so now let's take a look at this last example. A company puts a code on each different product they sell. The code is made up of 3 numbers, 0 through 9, and 2 letters. How many different codes are possible? Well, we have 3 numbers here, number, 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 and 2 letters. So how many number options do we have? Well, I have 10 the first time, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't see me, but I just counted those on my fingers. We have 10 for the next one and 10 for the next one. And then our letter options, well, we have 26 letters for the first one and 26 for the second one. So I multiply 10 times 10 times 10 times 26 times 26. I'm going to end up with 676,000 options. So that's just 3 numbers and 2 letters. Imagine the combinations that we could have if we had 8 numbers and 7 letters or something like that. We can look at millions of possibilities here. So in the next couple of videos, we're going to be discussing permutations and combinations, which are related to this fundamental counting principle by looking at what our possible outcomes are. But we're going to look at them in situations where order matters and when order doesn't. So please check out the next video on permutations, where we talk about how we can count something when order matters. And then the following video on combination, where we count something where order doesn't matter.